Hello, my name is Madison Sigg, and my project is the effect of land use on water quality. In this experiment, I tested to see how land use affects the quality of the water of Rock Creek. Rock Creek is upstream of the Chesapeake Bay, so what happens in our water will end up contributing to the water quality of the Chesapeake Bay. We need to restore our bay to help save it and its resources. If the testing site of the stream is changed from rural upstream of the wastewater treatment plant, downstream of the wastewater treatment plant, and downstream rural that is passed through the town, then the chemical parameters that indicate stream health would be in the healthiest range, upstream rural, because as the water is moving downstream into the city, the stream may pick up more waste and pollutants from the land use and other emerging streams as it travels through the town. The independent variable for this experiment is the location along the stream that is being tested. The dependent variable that will be measured are the levels of dissolved oxygen, nitrates, pH, water temperature, conductivity, and water transparency. The control for this experiment is the day that all the testing will take place, as well as the time the tests are complete and how the samples are collected and tested. This is a field scope map of the stream sites I tested. I was originally going to test different sites along Conewago Creek, but it was very hard to access those sites. So after consulting with Miss Bird from Gettysburg College and Advancing Science, I chose to evaluate Rock Creek instead. Miss Bird trained me as well as my class on how to use GLOBE protocols and the equipment. Mr. Toth trained Miss Bird and my teachers on GLOBE protocols and data entry on the GLOBE database. This is Site 1, downstream rural. It was shaded, had a vegetated bank, and a limestone bedrock. This is Site 2, downstream of the wastewater treatment plant. It was shaded, had a vegetated bank, and rocky, muddy stream bed. This is Site 3, upstream of the wastewater treatment plant. It was slightly shaded, had a vegetated bank, and a muddy stream bed. This is Site 4, upstream rural. It was shaded, had a vegetated bank, and rocky, muddy stream bed. Dissolved oxygen is the amount of oxygen that is dissolved into the water. It is important because without oxygen, the organisms in the stream wouldn't be able to breathe and would die. Conductivity measures the amount of electricity conducted through 2.54 centimeters of water. Conductivity is important because it tells how many different particles are in the water. pH is the measure of the concentration of hydrogen ions in a solution. pH values of 7 are neutral and are good for stream life. Low pH values are acidic, high pH values are basic, and these levels can be harmful to organisms in the stream. Nitrates are a form of nitrogen, which also include ammonia and nitrites, which are essential plant nutrients. Organisms produce waste, which turn into harmful ammonia, which bacteria breaks down into nitrites, which are also harmful. The nitrites are broken down by bacteria into nitrates, which are not as harmful. If there are too many nitrates, then many plants grow. Sunlight can be blocked or nitrates can run out. The plants begin to die and fall to the bottom of the stream. Decomposers start to break down the plants, using up the dissolved oxygen, and then a dead zone occurs. Water temperature influences the diversity of the aquatic life of a body of water because different organisms can survive different temperatures. Water transparency measures the clarity of the water, which is important because the clearer the water, the more sunlight can reach all plant life, even at the bottom of the stream. Water transparency was measured using a homemade transparency tube following GLOBE protocols. The results show that dissolved oxygen increased and peaked at all sites on week 2. The levels of DO then decreased slightly during the remaining weeks. Nitrate levels varied between sites during week 1. Data collected during weeks 2 through 5 is inconclusive due to change in available testing materials. pH levels show a decrease at all sites during week 4, with the most dramatic decrease being found at Site 3. Water temperature levels showed that during the testing time, the temperature decreased as the weeks went on in correspondence with the decreasing air temperature. Conductivity levels showed that during the testing time it rose slightly as the weeks progressed, peaking during week 5. There was a slight outlier during week 5 at Site 2. Transparency levels showed that during the week there was a slight increase, peaking at the end of the week. Site 1 had the consistent level during the whole testing period. The dissolved oxygen temperature graphs show that for the most part, as the temperature dropped, the dissolved oxygen went up. The conductivity and nitrate graphs show that when the nitrate levels were at 5, generally the conductivity levels were in the 400s. The conductivity and transparency graphs showed that the higher the conductivity levels, the higher the transparency levels. Even though all the sites had very good water quality, the results support my hypothesis. Rock Creek is one of the major creeks flowing into Marsh Creek, which flows into the Monocacy River, which flows into the Potomac River, which flows into the Chesapeake Bay. So essentially the water quality of Rock Creek has an impact on the Chesapeake Bay. The land around Site 1 is mainly deciduous forest, low-intensity developed, and woody wetlands. The population density of Site 1 is 0 to 400. The land around Site 2 is low-intensity developed and cultivated cropland. The population density around Site 2 is 0 to 400. The land around Site 3 is deciduous forest, low-intensity developed, and grassland. The population density around Site 3 is 0 to 400. The land around Site 4 is deciduous forest and low-intensity developed. The population density around Site 4 is 0 to 400. A future experiment would be expanding the testing process and seeing if results kept the same consistency over a longer period of time and throughout the changes of seasons, specifically involving weather events such as snow and other changes in farming practices over the seasons. If this experiment were to be repeated, the tests would be done consistently 2 times a week for a month to see the changes throughout the month. Rainfall events would also be monitored and analyzed to determine if there is a correlation with the changes in pH, conductivity, and transparency. The wastewater treatment plant would be interviewed and a request for discharge and quality data would be made. Blasting times and locations from the nearby quarry would be requested, documents and analyzed for correlation to trends or outliers in stream quality measurements. Statistical analysis such as t-tests would also be performed to look at outliers and accuracy. Further experiments may test the effects of other water quality parameters and macroinvertebrates to set a long-term picture for the health of the creek. Alkalinity would be tested to evaluate pH and stream bed geologic makeup. A map of the rocks and minerals of the Rock Creek stream bed and watershed would be analyzed to better understand data trends. Other creeks in the area would be monitored as well to compare the health of all creeks in Adams County. After becoming comfortable with GLOBE protocols, I became a student trainer for other students in my class as well as grades 6 and 7, who learned to use the protocols and equipment for the class hydrosphere investigation. Thank you for taking time to listen to my presentation on the effect of the land use on water quality.